Well, hello everyone. We'll take a couple more minutes waiting for people to join, and hopefully the volume and everything is okay. So see you in a couple more minutes. All right, hello. This is extremely exciting today. I have been cooking this for a couple of days now. Last time we spoke a bit about the data structures we might use. Today it will be much more interesting than that because we will try to implement a vertical slice. And in the meantime, I want to revisit what we spoke about last time from in terms of like data structures. I had enough time to think about it a bit more, and I think I came with different approaches to do that. All right, so first things first, I need to make sure that we are talking the same language about what is our Notion document might look like, right? And it might look something like this. And here, as you can see, okay, just making sure that like the stream is going okay. All right, so here, as you can see, we've got a Notion document. When you visit Notion, this is typically where you land in, and you tend to see like a document, and that document will have like a title. You could have paragraphs, pages, and there's so many amazing things that you can do in Notion. Like you can embed calendars. They have the concept of databases, and we need to find a common language for all of these things. So anything inside a document, we will refer to it as a segment, and each segment has a type. So for example, we have a text segment, a document segment, a calendar segment. When we embed a document inside a document, it becomes a document segment. So that's the first thing that we needed to define. So we defined what a document is, we defined what a segment is. Now, if we look in Notion, typically on the left hand, you kind of have like pages that you can visit like right away. And I want to call these document tree. And the document tree is when you open like the capture page, you can even like, you know, like toggle it, and you have a list and a bunch of things that are inside it. So a capture page, for example, would have like many things inside it. And if we want to look like into a real example, I'm getting you into my notes, my own personal notes. That's how special you are, you know? Not many people get to see that, but anyways, of course, if you're here, you're absolutely special. And thank you for joining, anyways. So you can see here like the capture, right? You can toggle it, and you can see like you have different pages. So in a way, you can think about it like folders on the file system. Okay, so now what? Now it's funny how we mentioned the file system, because indeed this is what we need to kind of like model this on, and we'll do like some changes. So let me grab this full diagram here. So when you're using Linux or Windows for that matter, like in many systems, you have like the concept of a folder, and that folder include files. And we want to model that structure, because if you have a document, this document could have documents inside it, which means it's kind of like acting as a folder. The big distinction here is in file systems, specifically in Linux, for example, on Mac, your file can hold text, but it cannot hold other files. So that's the biggest distinction that we want to do. So in a regular file system, you've got your root, right, which is like the slash or whatever, and then you have like folders, so you can see like documents, downloads, yada yada. And then each of these folders can have multiple files. And you can even have files straight on the root too. Like the root is just a directory essentially. So we need to start defining a bit of rules about how are we designing all of that. So what are the rules in terms of like creating a document? Well, I've wrote some here, and let's explore them together. So in our new mock Notion that we're building, right, we will have one root document as well. And you can think of it kind of like the root directory in a file system. And the idea is you need to attach a document to a known location, and that known location for us will be a root. We will also allow for duplicate names. So in a file system, if you're inside the same folder, so let's say I'm inside folder 1, I cannot create two files with file 1 and file 1, right? That is just not allowed. Let me just demonstrate it here. Bam! I think that's big enough. All right. Right, here's our amazing terminal. So now, I have this directory called live stream, and let's say I want to create file 1. So file 1.txt. If I do ls now, I do see file 1.txt. Okay, great. So now let me create another file, but this time so here I'm trying to create a new file with the same name, right? But it actually didn't create one, it just wrote inside the first one. And that's a big distinction. in Linux and Mac in that case, right? Each file has a path, and it plays a critical role into how you find files, write to files, and interact with them in general. So that is something that is very important for us to realize. But in Notion, you can create two files with the similar name. So for example, let me go to my live stream here. Great. So inside my stream examples, I do have two files called sample document. Right. Sorry guys, be right back. Alright, I'm back. Sorry. I'm just like desperately need a cup of coffee, to be honest. I started working out recently, and yeah, my buddy's not having it. So anyways, so as I was saying, inside Notion you can create multiple documents with the same name. So how would Notion know which document are you actually referring to? Well, they must be using a different mechanism that is not the path. So what is it, right? And it's essentially just IDs. So what they're doing is, for each document, or that's what I at least would assume the solution would be, they would create an ID for each document or each segment, and when you click on it, you're interacting with the ID. The name is just a display thing. It's a fluff. It's a glitter, right? So it doesn't even matter, because in fact, in Notion, you can create a page without a title. So the name has zero significance in it. This is an empty page. It's called untitled. It doesn't have anything in it. So really, all what it is, this is just an entity, and this word is gonna come handy very soon. So it's an entity just with an ID. Okay, fair enough. All right. What else? So these are our rule sets, right? This is right here. I literally just like pointed as if like we're talk as if you're in the room with me. But anyways, the third thing is we want to be able to select the document as an anchor. And this is something like a feature request. I don't know, maybe it's there in Notion, I don't know. But every time you visit like notion.so, it just kind of like puts you like in this random page. It's consistent, so I'm sure they pick an anchor, but I'm not sure how do they pick this anchor. So I want an explicit way of defining it, saying that whenever I go to Notion.io, I want to be able to land into my projects page, right? Or into my capture page. I don't want just like this random document to appear. And that's an important feature that we will implement, because guess what? If you don't like it, go implement it yourself. That's the motto here. Okay, so we have explained the main rules that we want to address right here. Great. Now what? Well, how are we gonna model the document tree? And how are we gonna model the segments? This is kind of what we spoke about last time, but now I come here with clarity. I represent to you clarity. Great. So one solution would be, let's address the document tree first. So we want a way to be able to find documents pretty quickly and conceptually nest documents and be able to find them. Of course, removal is important. Of course, like adding more documents is important. But the main criteria is we want to be able to find documents fairly quickly and be able to nest them into a tree structure. So when we say tree structure, people think for the longest, well, at least me, for the longest time, right? I kind of thought like the document tree must be implemented like a document tree. And I have this obsession about operating systems. I don't know why, it's just a topic that I absolutely love. And when I was studying operating systems, you learn pretty quickly, especially if you're like studying Linux internals, you learn pretty quickly that that tree isn't necessarily a tree. And you start like feeling like, what is going on, you know? Like, you're saying it's a tree, it's literally called like document tree or like file system tree, but it's not implemented as a tree. So what is it? What is it? Well, let me copy this section here because it's something that is absolutely amazing. Let me introduce you to the inode, the index node. Some of you might be familiar, some of you are not. But in Linux, the entire file system have an inode table, and it is just a table essentially. And all of that table includes is an identifier, so an ID for each file. But remember, we also have directories, right? So how would we find all the files inside the directory? Well, each inode entry would have like a type, and if it's a type directory, then this directory would have some information to like that, they call them data blocks, and we'll look into that in a second. But it essentially have like other pointers to the files inside it. So that's pretty interesting. So you actually have a table that would get traversed to be able to build a tree. Okay, so let's look into that. And maybe this is very similar to our structure that we want to create. And if that's the case, we should probably use that instead. Okay, so introducing the inode. Each file and directory in the file system has a unique entry in the inode table. We covered that. This entry records various information about the file system. So each part of that inode table, so like let's say you have file 1, right? That file 1 has an ID, but it also has file owner, it has a group, access permission, timestamps, pointers to the data block. This is where actually the true content are actually written to desks and much more. And if I go to my terminal right now and I do ls/li, that number right here is the inode number, right? But you also see, so you see the inode number, then you see a bunch of permissions, you see the owner of it, you see the groups, the creation's date, I don't remember what this column is for, the time, and the file name. So, and there's so much more that is actually going behind the scene. I don't know if I have stat. Yeah, let's run a stat. Okay, so if we run a stat right here, we also see multiple dates. And we see the 4096. So what are these, right? Also, we see the 67728. Okay. I actually haven't prepped for that 16, the number 16 thing, but what if I go back and I do ls/la and I add the inode number for live stream? Well, I can't do the live stream because I want okay, so here the live stream directory, which is the dot inside the live stream, has that ID. Great, so that's the correct ID. So this number then must be something else, and we can pretty much like look it up or something, but that's okay. That's not the point. I might create other videos about Linux and it will be a lot of fun. So the point being is you have a lot of metadata that is actually being stored, and that is an important thing to know, because we will use this metadata to build a real system. So for example, in Notion, you can share a page with a group, which is kind of similar to Linux. In Linux, you can have multiple users in the system, and maybe they can like navigate to my folder, but they can't actually open the file or even open the folder if they're not part of my group. And the whole point of this stream is that we build something realistic with real challenges. I'm not here to teach you how to do like a GET request in HTTP. I'm sure you know that, or I'm sure you can figure it out. There's plenty of tutorials. So what we're doing is figuring out the other stuff that nobody talks about as much. Okay, so we will model our application kind of similar to the Inode. But let's explore the Inode a bit more, and then we gotta move from that and see how this would help us. So why does Linux have it as an inode table, right? Well, it allows the inode to be a fixed size, meaning like that table could be like 13 or 14 entries, and it's able to manage like huge and massive files. Guys, this is an absolute oversimplification of what's actually happening in Linux. And by the way, this is from the Linux internals API book. Beautiful book if you want to learn Linux internals. I think this was like chapter 13 or so. But yeah, I totally recommend reading it. So the idea again is that you're able to like quickly find files, and you're able to build the entire tree structure if you want that tree structure by just like traversing like this table. I hope that's clear. Great. Okay. I just want to read this section for you because if I include it here, this must be important. So in Unix, there's a single inode table for the entire file system, right? So we do not actually have like an inode to point to an inode. No. It's a single table of an inode entry. That's all what it is. And each inode in the table stores the metadata for a single file or directory, including the data blocks. Data blocks means like where the content is actually written. So when we find the directory, the data block for that directory is just simply like, you can think of it as an array of IDs for files. And now these IDs are also part of the inode. Okay, that's great. And when we access that directory, you traverse it. Wonderful. So now what? How does this help us? So we want to adapt that concept of the inode into our use case. So when we have a brand new user and you're creating the account the first time, Notion typically would have one welcome page or one welcome document for you, right? And we'll do the same. So under our root or our inode table, we'll have like one document in it. You can delete this document though in our application, and when you create a new document, it will be automatically added to the inode table. If the inode table is empty, the first document you create will be the anchor document. Okay, so this is more of like our criteria, right? You can nest documents as you wish, and we want to create like the tree structure we conceptualized. Oh, and yeah, the last thing, we don't want to worry that the file name is not unique. And simply, our entire data structure for that might look something like this. Of course, again, this is an extreme oversimplification, but really you can think of it like you have a document ID, and each document ID has a corresponding pointer to that document. Right, and this is why it's called an index node. So each node would have its own name, order, group, access permission, last edited, last accessed, created at, and documents ID. Now, few things that we need to pay attention to. We do need a lot of these metadata if we want to implement the real system. For example, in Notion, if you're doing collaborative editing, which is a huge topic that we want to get into at one point in the stream, you want to be able to know what has changed over time, and last accessed at least could give you last edited could give you the date and the time of when this changed, and we can add other mechanisms to actually know what segments has changed, and we can diff them, kind of like git. So that would be interesting. Another thing to pay attention to is the document IDs here. So a document, if you're modeling this, if you're thinking about this problem in terms of like a document database or just like nested JSON, you might think that I will have my document, and if this document has subdocuments, I would have an array of documents inside it. But there's no point. You have an inode table. So just inside this document, say which ID you want. In this case, this root document have 2 and 3, which are part of the inode table. So if I'm accessing it, all what I have to look for is like, where's my document IDs? 2 and 3. Okay, inode, give me document 2. Does it have any children? No. Give me document 3. Does it have any children? Maybe. And that's the whole point. It's an instant time lookup if you have an ID. That's pretty amazing. And also, you're saving shit ton of like space, I want to say, because like you're not just nesting documents and traversing and copying documents over. No, there's one location for documents, and that's an important thing. Okay, so we spoke about, this is going to be our data structure that will support our application for the inode. And now we can switch to another fun topic, which is the segments, right? And let me just, here I have some notes I wrote that I want to make sure I cover because it's absolutely fantastic. By the way, we will write some code for the inode table today, and we'll also write some code for the segments, which is the next topic. Let's see how we're doing, if we have any questions. Nada, nothing yet. Okay. All right. So the data structures for segments within a document. So if we go up, we saw here that we've got a bunch of segments, right? And last time we spoke about that we can have a document potentially have a bunch of segments into an array. But now we have some challenges. So one, oh, this font is way too small. Bam, bamboozled, 28. You know what? Let's just do 50. I want to make sure you all are seeing what I'm doing. Let's just do that. Sorry, 1 second. And I need a font, please. You know what? You can just do that, because I forgot the font name. Bitty. Okay. So now what? So point 1. We need to be able to insert the fast insertion. Meaning that if I'm authoring a document, I really want to make sure that it's pretty damn fast to add text to it, or segments in that matter, right? In Notion, if I go here and I click and I do like a title, hi, this is actually pretty fast. Not pretty. Okay, so this is actually pretty fast. So we want fast insertion. We also want fast deletion. fast deletion, and fast reordering. I'm pretty sure, yeah. I'm a bit dyslexic in that sense, I guess. Anyways, so you want fast insertion, fast deletion, and fast reordering. And the reason being is like, when you're editing text, a lot of the times you're actually like either inserting a lot, so like you're writing, you're in the groove, then you go into like the editing mode, and that editing mode is like, hey, I don't like this, delete. I don't like this section here, let me reorder it. And if you do this with arrays, now every time you expand beyond a certain point, it will have to create a bigger array, copy everything over, and then continue appending to that, right? So that's if you use an array. Okay, and you might argue, well, an array, if you know where the segment is, you can have instant, like you can find it quickly. Sure, that's, you need to use like another data structure to keep track of it. Oh, requirement 0, and this is also extremely important, is ordering. We want to make sure that we maintain the order that the segments are in. That's very, very critical. Great. So we have ordering, we need fast insertion, and we spoke about like, now the array wouldn't work because what they call the amortized time, which is the time it takes to grow the array. Same for deletion. If you delete an array, it's actually like quite terrible, because if you delete in the middle, you need to shift everything from the right to that, right? If you're removing the end, sure, not too bad. If you're removing the beginning, right, you also need to shift pretty much everything -1, so it's heavy, okay? And fast reordering swaps is not as bad, but we can do better. So we looked into linked list last time, and when we looked into linked list, you maintain the order. It's fast insertion, because when you're inserting, you're just changing one pointer, so that's great. Deletion is O of n, meaning that you'll need to find the segment that you want to delete, but the delete operation itself is almost instantaneous, so it's not too bad, but we can still do better. Fast reordering, fairly, you can move things around fairly easily on a linked list. But what about though if we do something a bit different? So what if I have here, I think it's called, yeah, I know. Brain to front. Okay. So now, what if I have my root segment here? Actually, this is a document. So this is my document, and I want to look into the segments. Okay. So I have a document here, and it has a bunch of segments, right? Segment. Well, actually, let's give them a name. So header 1. And now I have, for example, another header 1, and here let's say, actually let's model that. So I have a header, I have text, I have another text, and then I have a bunch of documents. Okay, So what if we model it as a tree? Last time we spoke about this a bit, right? And we ran into one problem. And that problem was, at the time, is like, let me just actually do that so it's crystal clear that we're talking about a tree structure here. Bam. Sorry, it's a bit laggy. Great. So I guess that's kind of like clear that it's a tree, right? Okay, so if each document has a segment and now we have this tree, how are we going to maintain order within the tree? And that's kind of like what got me last time, because last time I kind of was like looking for one data structure to like maintain the order, maintain the segments, but really you don't have to. You can use a supplementary data structure to kind of do like bookkeeping for you, and another one that is handling the segments. Sure, it does take a bit more work, but at the end of the day you get much of a better like overall either performance and like a better model, and it's much easier because you get like the best of both worlds and you get a bit of a trade-off, but it's an acceptable trade-off for now. So here's what I want to do. The tree wouldn't maintain an order, so we need another thing that actually maintains an order. What could that be? Well, you might say it's either an array, it's either a linked list, or we can do like a set or something along those lines, right? But if you really think about all of these, you still get a bit of like the same problem that we kind of spoke about with the segment, right? Sorry. Sorry. Okay. So if you use an auxiliary data structure, you will have to like use an array or something like that. But what if this auxiliary data structure is actually within each node? So you're not just like storing a pure segment, you're storing a node, and that node has a segment, and that node has a tree of children. And the way I came to find that, and this is not 100% accurate, but this is my current understanding of it, is actually the DOM. If you look into HTML, the browser, well, it builds a document tree, right? It knows that this is a header, this is a div, yada yada, meaning that it's also maintaining order. So how does it do that, right? Because it's really like exactly what we're building here, but I don't want to build the entire DOM again. So you have your document, you have your segment, and that is the trick. Each segment would have a list, an ordered list of its children. So as you're assembling the tree, you're maintaining the order within each node, right? Of course, the DOM is much more complex than this, but this is working. So for example, if I say now like that I have a node, right? And now this node has children, which is some other nodes. This is the simplifications for now. And this is ordered, right? And now we can even do better, because this tree will expand much more. So you'd have like a header 1 might have a header 2 inside it as like its children, I mean 3. And as you can imagine, this tree might get like really deep, right? So now if this tree gets quite deep, you run into problems with like the slice. So you can say this is no longer just like a slice of nodes. You can say this is my children nodes type. And the children nodes type could be a linked list. Now, you have a tree that each node inside it has a linked list. This linked list helps us build the tree, helps us traverse the tree, helps us maintain the order. It's extremely fast in insertion, fast in deletion, fast in reordering, and you get all the benefits of the tree data structure, which is like when you're moving things around, you're only moving a partial view of the tree. You're not moving the entire tree. You get faster search. Like in that case, we can like do like a depth first search, and we can find the things that we want to do. So we're using concepts again from the file system as well, and we're implementing it here. Okay, now there's one last thing that we need to pay attention to, and then we can get into our third conceptual thing, and then we move into coding. All right, now that we have other document segments, and these could be nested pretty deep down. So for example, I could have header 3 that have a document, and let me get us some space here. Okay, so we have a document here, we have a document here, and we said we're going to be using like the inode structure, right? So if I'm using the inode structure, I can have another rectangle here that represents our inode table. Right? And it has these entries so it have these entries that are actually pointing to these documents. It's being quite finicky right now. I just want to move it. Anyways, you get the idea, right? It's like for each inode table, it's actually pointing to the document, even if it's a segment. Okay, great. So now we have like ideas essentially of how we want to model our problem in terms of like data structures. And we shouldn't have started there, to be honest. I reflected on that the other day, but it's still not a bad start. So that's good. So now what do we want to do? I want to get a vertical slice of how this all might work. So we need to start thinking of from the interaction of the client to our use case to what happens after that, and let's get coding. Okay. So the clients want to create a document. So our first use case is create document. They're brand new, they're just joining. What are the rules here of creating a document? I don't know if that's still visible enough. Let me make this even bigger. Okay. So now I'm in the create document use case, right? What are the things that we need to account for? Well, how will this document be created? That's our first question. Our second question would be, what rules apply to the document? Okay. Three is, where should this document be created? Okay, so now let's explore the rules a bit, right? So here, we're just gonna say rules. So our rule one is a document, as we're actually, I'm not gonna write them down, right? We kind of have them, we have them up there. So the first thing is a document must have an ID. Well, you know what? I think we should write it because we're gonna need this in like our tests and our code anyways. So we should be explicit about it here. So here, a document must have an ID. A document name is optional. Okay. A document must have root as a parent or a valid document ID. And this is an important rule here, right? As a parent. Yeah, so this is an important rule here. If you're trying to create a document and that document doesn't have a parent ID, this means it's inside the root. So it will go like somewhere around here. Okay. But if it has a parent ID and that parent is invalid, then you're trying to create a document within an invalid document. That's a rejection. That's a bad scenario right there. A good scenario would be is like, you're giving me like the capture document ID and you want to create another document inside it. So I know now that it's inside the capture document ID. And as we kind of already have a conceptual view of what that might look like, well, it will simply append it to the document. So if I'm trying to create a document inside like the root, then I'll add it to my Inode table, update the document list IDs, and off I go. Great. Do we have any other rules that we might think of? Okay, I think that's good enough for now. So I created a GitHub repo. I'll put the link on the description. Actually, let me write the note about that. Shit. Put link to repo. Yeah, and it's the Notion backend. So go ahead and clone that. It's empty right now. I have zero code in it. And let's do this. Okay, so we're inside the Notion backend. I'll open Golang. when I'm running OBS and Notion and a bunch of other stuff, and like I'm in the browser and everything, it's really take a toll on my Mac. It's a pretty old Mac, so please be patient. So yeah, it's either that you wait a couple of minutes or we'll start doing it in Vim moving forward. Yeah. Alright. So let me zoom in. If things actually work for a second here. And we just say zoom. Great. And now let's see what we want to do. I'm gonna have like a tiny editor here, so everything could be shown quite clearly. Bam. Bam. Okay. So first off, I want to go ahead and I want to create a directory for our create document, right? But what I want to do is I'm gonna have like my domain, and I'm gonna have my shared. This is just kind of like templating folder structure that I liked, and we can go from there. So now we have like the document, right? Typically, I wouldn't even like start with as many nesting, and you know what? Yeah, let's do that. So let's just simply start with like, we're just gonna create one folder, not a scratch file, just one folder. And we will have this one as our command. We will learn why I put this there a bit later, so we'll see. And now let's create the let's create the document model first, right? Okay, so we don't have any I want this to be document. Here is my document package. Great. So we need to start thinking of like, what would a document look like, right? Well, we have decided that it will have, let's just include the things that we know for sure it will be there, and then we'll improve it, because we kind of like already did the thinking really here, right? So we kind of know exactly what will be inside the documents, but still. So we'll have a type of a document, which is a struct. Okay, and now we'll have it will have an ID. An ID, that would be a string. It will also have a bunch of other documents, so documents, and that will be a slice of IDs. So another string. I can create a type called ID, is here, and I can replace this with ID. Great. So now what? First off, this here, we'll first add our first to do, change to link list. Great. Okay. So this is our document. This is just like the very bare bone of a document. Of course, it also have a name, which is a string. Great. And now I want to create a service that will be used. What I mean by that is when the client comes in, whether that's GraphQL, whether that's REST, whether that is CLI, I want to have a very defined API they can interact with to operate on documents. We'll only focus really on like the client as like probably just like GraphQL at that point, or even REST, but like we'll just think web, right? And here when a client like tries to create where is our tree? Yeah. So when someone is like creating a document for the first time, they want to click a button and that would create a document. So something has to say create a document, something has to go through the rules and all of that. This is typically called a service. So we're gonna have a type, and this will be a document service, right? And this is gonna be another struct. Now, the document service will have to handle the validation, it will have to handle getting the request. So the request is coming from the API. The API is giving it to the document service. The document service is doing a bunch of stuff. And we'll see exactly what are these things are. You've got a couple of options, right? And we haven't like started writing tests, which we should get into in a second, but you can essentially like define an interface right away, which you say like, let's say, like rather than the document service becoming a struct, you can just actually make it an interface and you define your methods. So you can say like create document. This becomes your interface and you have like a type doc server, or even like right type document service, which is an actual struct that implements the iDocument service, right? So your document service becomes that interface. We will scratch that for a second and we'll actually go and try to write a test and then see what might we need, right? So here's what we're gonna do. So we're gonna go and go create a file of document test. I'm actually gonna call it document service test, right? Also, in Go, typically your files are all like lowercase, so we're just gonna change that to a lowercase file. Okay. So let's write our test, and also let's try write it from an external point of view. The difference between an internal test and external test is when you add like the underscore test, Go kind of looks at it as like, now this is an external package. So only things that are exported, you have direct access to it. And if it's not exported, you will not have access to it. So there is that. Okay. Now let's write our bare minimum create basic create document test. So create test for create document. Now let's imagine how our API is gonna look like, right? An API in this sense, I'm only referring to like your methods API, your local API. I'm not talking about external communications APIs. Okay. Alright, so the test create document. First off, I want to be able to create a document, so I'm gonna say document. I want to create a document service. So we need document service dot new. So I want to create a new document service. Of course, everything will be red, but that's the whole point, right? So now that I have a document service, what do I need to do? I'll say document service. I will actually say I want to create a document. So a document, I want to create will be a document type, right? And I want its ID to be 1234, and I want its name to be my first document, and my documents will be an empty list of strings. So that's how I want my document to be created, right? I might not exactly care about the ID yet, so we'll get back to that, right? But of course, we missed a few things, which is go mod init. Let me copy that. And I want to install this library called compare. It's by Google. So go get. I have it here somewhere. Yeah, right there. So you see it's like the Google Go Compare package. And it will help us a bit in the text and the tests. That's the library, by the way. It's pretty handy. So let's see how we're gonna use all of that. So now this is the document, right, that we want. And now we want to create, so document service. Create document. And here is my document, right? And I need to be able to retrieve it back to be able to evaluate it, right? But the first thing is, when a document service creates a document, where will that be stored, right? And typically, you will do a repository, and that repository would handle how your service stores information. So that could be writing to the database, that could be writing in memory, and we're testing, so we need access to it without any extra infrastructure. So we'll actually just do an in-memory. Great. So this means that we need to create a repo. So I will say document in-memory document repo equal new document repo. Document repo. So now I have the document repo right here. I should be able to pass it, right? To pass it in. So you can pass it in directly, but this is not the ideal API we want. So the API we kind of want to look like is that you don't want the document service, you don't want the user or your client, for that case, to try to remember which argument goes where. That's kind of like very annoying. And what people typically do is they would have like a config object and they would pass it down. But if you do that, then you've already configured your service. So why create it outside and then pass it in? So we need something in the middle, right? And that thing in the middle is you define your defaults. So you don't have to create the full object, and then you merge these defaults with the user. So for example, here we can say document service dot with repository, and you pass it to the in-memory repo. That becomes how you configure your document service. Just pass it functions, you can create your own, and we'll see how that is done. It's pretty cool. Okay, now that you ran like the document service create document, now what? Well, I want to check if it's actually wrote it to the in-memory doc repo or not. So I'm gonna say in-mem doc repo, and pretty much I want to access it. So I will say get documents by ID, and I will say document dot ID, which is this document right here, right? But yeah, we'll see. It's complaining that like it can't even find this, right? Which is unresolved reference, but in our case it will be. So don't worry about all the reds. Just try how you want your code to look like, evaluate it, then we'll get back to that. Okay. So now, here we can say got. And this is a convention in Go. If you don't like it, you can change the name. It's just a variable name, so do whatever you wish with it as long as it's clear. In Go test, typically you say want and got. So this document right here, right, you would typically call it want and you compare it with what you got. So here's what I'm gonna do, just so we're like absolutely clear. This document right here, I'm just gonna change it to my one document. Okay, so now this is my one document, and here's my got document. Now what? Well, I need to compare both of them together. So I will do if they're not equal, one document with got document, then test it'll and show me what's the difference between them. Okay, so we wrote a test that like pretty much all of it is failing, right? So from the document to the in-memory to even like the use of like the word doc service and stuff like that, and even the package, right? Okay, so now let's try to get this to be working. First off, I want to create, we want this to be inside the doc service package, and then we'll move things around and reorganize. So I will move this from document to document service. And this will be my package. Okay, so that is the very first things that we have fixed. Also, let's make these public for now, and I will show you how we can fix this in a second. I will remove that concept of a document service just for now. And we'll say that this document service have a repository. And again, that's exposed. We'll fix that because I don't like it being exposed. And this repository is going to be document repository. So let's create that. And this is going to be an interface. And the method that we wanted in it was get document by ID. So you pass an ID. I'm actually just going to pass a string for now. And it should return a pointer to a document. Great. And now when you create new, this should return a document service. And if we return here a new document service, and we set the repository to in-memory repo, right? But let's actually create an in-memory repo. As you notice, I'm doing everything in one file. We will reorganize, we'll make this beautiful and clean with like clean boundaries. Right now it's just like, let's just get the test working and then we can discuss cleaning it up, right? So I will have an in-memory document repo, and that will be a struct. And here I'm gonna say this is my Inode table, which is gonna be a map of IDs that points to a document. And for the first time we use one of the concepts that we've been talking about for the past hour or so. Okay, now what? So now that I have the in-memory document repo, and I hope that's still like clear, let's implement the very first method on it. So I want this here to implement the document repository. Okay, so we have this get document by ID, and we want to implement that, right? And simply all it will do, it will go to the inode name. It will go to the inode table and retrieve the document if it exists, and if not, it will return an error. So first things first, let's say it will return an error. We have just discovered that when we're designing. Again, anyone, if you have any questions, please drop it in the chat. It would be absolutely nice to like interact with you and get to help you understand what this is. Okay, awesome. So now the get document, first thing we need to check is it inside the inode table? Does it exist in the inode? So we're gonna say if the document and exists inside the inode table ID. So if it exists, just return document and nil, meaning that there is no error. Otherwise, return nil, and we can create our error document with ID doesn't exist, right? And here you can pass the ID. When we're cleaning up, one thing that we can consider is actually creating like custom errors that the user can like compare, and that will be beautiful because now the client could be like, is this error doesn't exist, or is it like of that particular type? So that would be quite cool. Sorry, be right back. All right, let's get back to it. So we've implemented the get document by ID, and it's very basic right now. We also want to be able to insert a document. So actually, let me refactor this. I want it to be exposed, and we'll see why for now. It will help us in our test, but we also need to like do a bunch of other stuff. So this is for the get document. Now I also want to be able to add document, right? So in a repository, let's say like save document, and you will just pass a document and it would return an error. Now we can go I don't know why, it's just giving me a bit of OCD. I want to get first. So we'll do like I for the in-memory document repo, save document that takes a pointer to, no, it's a doc, takes a pointer to a document and returns an error. And here, simply all what the save is going to do, since we're just dealing with a map, we're just going to say, hey, for the inode table, we can just say doc.id equal the doc. Right? And now it's complaining that this is not a string. So you can say a string doc.id, and now it works because it uses the strong types. But it's either that, so we can either like return it to like the base type, or we can take the inode table and be very specific that it takes an actual ID. It's a matter of preference in that case. I would put it as an ID and see how far we can go with that. If it gets ugly, we change it to a string. I just think it's quite clear here that I have a map of IDs and a document. So I think that's a better fit. And of course, here as well, you pass this as an ID. Okay. Now the save document is still not done because we know it to return, but there has no error occurred in that case, so just return nil. Awesome. So we've done a bit of the repository right here. Now let's get back to creating the document service. Well, actually, one last thing in the repository. No, a couple more things. I don't know if I want to make it so that it has like an inode table, to be honest. Especially that it's all on an in-memory. Or if I should just change that to that being the type, meaning like, rather than this, I can do that. And rather than this, I can do that. So I can be like, here's my inode. Or even like calling this an inode table. And calling this I don't know, I'm just experimenting. I still think that the in-memory document repo was much clearer, because what ended up happening is like you kind of hide the implementation detail here. So nobody actually knows how the in-memory document repo works as long as like it implements these methods. If tomorrow you go and you change it to like just a simple array or whatever, it's up to you. So this gives us a bit more flexibility. So let's just keep it like that. Now, a very cool pattern that I learned from one of the Go books. I think it was the Go tooling box, yeah, by John Arnold, and amazing book. Absolutely recommend reading it. And this thing is called like your configuration callback function. So you have your document service and you want to make it configurable, right? Like imagine there's like multiple things that you will definitely need to pass to the document service. It's not just gonna be the repo. Right now, this is the only thing. So simply you can just pass like a document repo here and off you go. But I want to do it in a way where we can expand it as our configuration items expand, or our properties on the service expand. And the way we do that is you create an option. So you're going to say, hey, I have a type. This type is called an option, which is going to be a function, okay, that takes a pointer to my document service and it returns an error. You can start thinking about it as a callback. But now, look how cool this will be now. So for my document service, I can have a function called with repository that I pass here a repository for it. Anything of type document repository, and it returns an option. Wait a minute. So you can say, and you can do your validation. So you can say if repository is nil, hey, return an error. And look at that. You have gave the power to your clients to configure your service the way they want to configure it and have access to it without having to overwrite all the defaults. This is beautiful. So now your with repository returns an option. So you can pass anything you want, do any validations you want. I don't know, but this is super cool. All right. So now you actually need to consider these options, okay? Because there's now, so now conceptually speaking it works, but how does it actually do the wiring? So now your factory, or when you're returning a new service, you can say options, which is a varg of an option. Okay, where's this going? So now if I create, this is my document, right? And I want to return return my document right here. Great, that's cool. Also, well, I'll get to that. I don't want to spoil it yet. Document. Document. Okay, here's the document. So now, how are you gonna get this configured? Well, I can say my repository here is gonna be my like DB repository if we have that implemented, right? So this could be my default right here. I'm just gonna comment it out because we don't want it complaining. But this could be my default, and in fact, this will be our default once we implement the database. Okay, now what? But now I want it to be configured. So I'm gonna say for each option in range options. So for each option, just literally go and apply it, and here you go. You got access to my document, and it's gotta return me an error. Now, what should I do with this error? It's up to you. You can inspect it and try to fix it. I would prefer, since we're like in a construction phase, I'd say return it to the client. They deserve to know about their error. So I'm just gonna say return nil an error, and here return nil. Okay, and that's it. Now it's absolutely configurable. And in fact, I just wanted to see that, like, how far we've gone into our tests right now. So the mmemory doc repo wouldn't be like that. Now we'll just say in document service dot in memory document repo. So here's my repo. But you know what? Let's stick to the roots. We wanted to create a new in-memory document repo. You got it. So on new in-memory document repo, I would return document repository. You don't return a pointer to an interface, you return the interface. And I think it's complaining this is not how you spell memory. Great. You know what? And now we'll just return an in-memory document repo, but we actually just want pointer to that. And let's see, what is it complaining about? So type document repo. The in-memory document repo type in memory as type document repository. Well, no, that is not true. It does implement. Oh no, it doesn't, right? That's because why doesn't it implement the document repository? So our in-memory doc repo, it has you see, there's why. So your git document right here, it's taking, we changed the type, so the signature doesn't match anymore. So we just have to do that, and all of a sudden it actually works, and now we can actually return a pointer as well. Okay, great. So this is the in-memory document repo. Remember, the inode table is a map, so we need to actually initialize it. Otherwise, you'll try to write a null map, and that's no good. No good. No good. No. Okay. For now, we say document service, and we actually use the proper name now. All right. Look at this. One of them is not red anymore. Great. And now the document service.new. Why is that? Why is that not working? Document service dot new, and it takes a bunch of options, but it also takes nothing. So what is it complaining about? Well, document service returns an error as well, so we need to return an error, and we'd say if there is not nil, just do the test and tell me what the error was. Okay, and also this is check working. Great. Now we need to create the document, but remember, we kind of exposed these things, right? So we set them ID, and so now actually what you can do is like document service with document, and you want pointer to that, and let me just implement them again. Fill all fields. Great. So here's my ID 1, 2, 3, 4. Name, my first document, and sure, let's have documents as nil for now. And let's spell document right. Okay, great. So we went from like the majority of this being red to the majority of it is not red anymore, right? And we can fix this part here. Okay. And we can fix this part here. I also just need to account for the error. Okay, error is not nil. Again, just fail the test. And look at that. We are left with the create document. Okay, so let's implement the create document. All right. So we can have this here under the options. I promise we'll clean this up. This is absolutely disgusting right now. Not because the code is bad, but because the organization is quite messy. All right, let's do this. So, fun. It's for the document service, so you're just gonna call it DS, not BS. Document service, create document that takes a pointer to a doc and returns an error. Return hell. Okay. That's good. Now, well, we know that the document service has a repo, and because it does, then we can utilize that to actually storing the documents. We spoke about the rules in the conceptual, but we haven't added the code to do the validations just yet. So we'll grow one step at a time, right? Now the DS will be repository, save document, and I'll pass it the doc. And you know what? I'm just gonna go cowboy on it since we're returning an error. But the create document will do much more stuff. So realistically, you will need a variable, and then you need to check it, and you need to handle things appropriately. Now our create document here works. Again, returns an error. Again, we need to handle it. Again, don't ever complain about Go error handling, because yes, it's verbose, but yes, you have to think about it. And that's what good software engineering is. You think about the errors. So, yes, that's what our ancestors say. Great, so now we run go test. So go test.testv. And I'm expecting a few things to blow up, maybe. Or maybe it runs. Alright, it blew up. Invalid memory address, or for nil, right? And where did this happen? Let's see if there's any clue. So in the create document, right? Let's see why. Okay, so we passed with the repository, and this repository is already I think what was it, F11, I think. Oh no. So if we go here, we have it indeed. Okay. So let me go back into the terminal. Runtime invalid memory address or nil pointer. So let's think about this. So if we go to create document, what happens? Well, first off, we're creating a new document service, and this document service have a repository. I wonder if it's because the repository is actually not being set. So, and I'll explain why in a second, but let me just do this to make sure that we're validating what we're validating. Okay, so that's not it right here. Segmentation violate. Okay, so I had a suspicion that the document service wasn't actually overwriting the repo properly. Because I thought we need to pass pointer, but then I realized that the document repository is actually an interface, so we don't need to pass a pointer. So now the problem must be coming from somewhere else. So probably if we go to the saved document and we go into the saved document right here, we're saying the Inode table. This is for the doc, right? Here. So this is all fine. We reach here, create document with address the repository. We'll go to save document, which is right here. And let me just add a good old breakpoint right here. And now we can run it debugger. If you spot the error, by the way, just let me know. Oh, so we've already panicked beforehand. Okay, so let's add it into our document here. Okay, so oh, you see that the document service is nil? How is that even possible? I created a document service here. Right, and then we say, here's my document service, run the options on it. If there is any errors, oh my god. Yeah, see, shit like that. So we're returning nil in both cases. There you go, guys. And now go for go test. Hey, that test passed. Okay, well, let's make it so the test doesn't pass, to make sure that like our document that we get is actually the same document, right? So let's do this. Since this is the proper document, let's just do something a bit ridiculous right now. If we do to the get document, and we do find the document, so let's do document dot name equal changed, right? Let's run it, and now it's passing. Oh shit! So this means that our test is not proper. So there's something in our test that is not okay right now, right? Okay. So let's make sure that we fix that. So right now we're saying that if the compare, this is my want document, and this is my got document. And we're saying that if they are the same, then it should be good. But even though that now we change them, then it's still not comparing them properly. Interesting. So what's happening here? What is happening here? So one way we can do this is, let's look into what returns from the got document. Let's look over it. So this is the document that we've received, right? And if we look into the in-memory, we see this is the key, the 1, 2, 3, 4, and we see that this is the value of it. So it's always passing because you're actually just comparing the same object every time. So you overwritten it somewhere, but you're still comparing it. So what you want to do is that you want to pass a pointer to this. Okay, so now I'm passing a pointer to the document service, and I will get that same one back. So yeah, I'm just thinking of something right now. What I'm thinking about is, first off, we did validate that the document that you pass in is the one that you get back. So actually your test is working. I'm just trying to think of, if I want to demonstrate that they are different objects, how can I do that, right? And the thing is, they're not the different object because you're passing a pointer, so you're always passing the same one. One way is to compare like the values. I think that would be like the only approach. Let's try to like do it so you can see it, but this is not how we're gonna do it, right? So I'm gonna say this is my one document, and this is my arg document, which is, I'm just gonna copy and paste this, right? And I'm gonna pass my arg document, but I'm still comparing my want to the got, right? And now this should fail and show me that the title has changed. My first document, boom! That's how you do it, you know? Just takes a second to think about. But anyways, we have validated that it's actually the proper document that gets back and forth. So there's no point of the test. I was just kind of like demonstrating how we would go about it. Because why not? If you can reason about it, most likely you can implement it in code. That's the rule of thumb. Remember that. You guys know that is going on my like story on my YouTube, my shorts, you know. Okay, now we have created a conceptual document without any validations and with very terrible organization. Let's organize a bit that will screw up our tests in a way, because we're going to be moving things around, and it really shouldn't. So our test structure will be the same, but let's figure out how we can do this. And right now we have everything in this document. So I'm thinking if I should do two-phase or one-phase. If I do two-phase, then I will move each part to its own file, but they're all in the same directory. If I do it in one phase, then I'll just create the directory structure and just kind of like show you. You know what? I'm running short on time, so let's just create the directory structure for now. I want to have domains. And the concept here is in Notion, we will have a user domain that's kind of like managing authentication, managing things related to user. So user profile, shared to other users, stuff like that. And we might also have billing, so we might have different domains, right? Or different bounded context. And this was an advice from one of my mentors, actually. And what he does is that he would create a bounded context directory to kind of like ensure that everyone is speaking the same language. And he would have a shared directory. We don't have anything in shared yet, so there is no point. Right now, our bounded context is documents. Okay? Oh, that's not cool. Okay, so now inside documents, I want to move all of these things. Bamboozle! Alright, so I have my documents here. Now I can create a directory called repository, which will be the repository implementation. And have a directory here called service, to be the service implementation. And here I will create a file called service. And that service.go file would just be the service. So if I search for a service, well, we don't have an interface for the service yet. I'll get back to that. But also let's imply the repository. So repository. Here's our document repository. Okay. You just move that and you just put it inside the repository. Great. Everything still works the same. Now everything related to service will be moved to the service. So from the option with the repository, then you create document. I actually moved the wrong repository. Why did I have it? Oh, I added the document service. Yeah, that's wrong. Let's fix that. But let's go to the service and create a new file. And we're gonna call this create document. And this is that. And we move this wrong thing here. We'll get back to fixing these packages. But let's go back to the document here and move the repository stuff to our repository file here. And inside the repository, we can do our implementation now. And that will be moving the in-memory repo. And we'll run into a cyclic dependency, so we have to think about how we're going to fix that. In-memory repo. And now documents to document, and we can change that everywhere. So Okay, no, that's not how we do that. Now, this is where like the ID type comes in as well. Okay. But to be honest, when you're inside the repository layer, you have already like validated everything and you're kind of like dealing with like raw data. So a string would do just fine here. And this would be a string. Also, this is actually a pointer. And this is where you say string is your document as an ID. And this is a pointer. Okay. And here's your document repository. And now what is this complaining about? Of course, the document repository is returning a string. Now that should be fairly okay. Of course not, because we still get, so this returns a string and a document. You see, it's still not accepting that it's implemented here. And this is also returns a pointer. And now everything works great for the repository. We have a cyclic dependency. We haven't touched that yet. So, and if you're not really aware of what I mean by cyclic dependency, is your repository right now is accessing documents, right? So you have this package called repository, and it's referring to this package of documents, and the documents package is referring to the repository. Where? We'll see. We'll see if what I'm saying is actually true or not after we reorganize. Everything should show up on the tests. Okay. Now for the service. Now the service requires the repository, so I can say document repository. Great. Similar for this guy here, and similar to this guy here. Well, actually, no, this is a document, right? So documents.document. Great. So my service depends on the document. Okay. Now, here, this is documents. This is actually going to be repository. New in-memory repository. And this is where we might run into cyclic dependencies, because now the document test is referring to the repository, and the repository is referring to a document. So let me show you what this means, and then we can reorganize the test, because this is not the right place anymore for it, right? So now this would be service.new. This is exactly what we're doing here. This is also going to be service with the repository. Great. And now this is actually documents. Yeah, this should be documents, right? This is, we go here, documents, the document. So what is it complaining about? import. Great. And now this by ID, we need to put it as a string. And great. Now, most likely we'll run into the cyclic dependency and it will make sense and we'll need to reorganize it. But let's see. CD bounded context documents. Great. So they're inside the bounded context now. Okay, it actually passed. It didn't run into cyclic dependency. Interesting. Why? Because in here you have the new in memory, so this is referring to the repository. Okay. And the repository is referring to the documents, but we are doing it as an external test. I wonder if we do it as an internal test. Let me do this. Just indulge me for a second. Because I remember I ran into cyclic dependency, import cycle not allowed in test. I'm telling you, right? So, because we're inside an internal package, it's kind of thinking that this code belongs to this package, which is the whole point of internal. And what ends up happening is you're saying, I have a repository. So you can imagine an arrow happening from this here to the repository directory. But the repository says, I deal with documents. So it has another arrow from there that it's pointing to the document. It creates a cycle. That's a very bad thing. So, yeah. But when you do an external test, it's kind of thinking that this is completely isolated package, so you wouldn't run into these issues. However, that being said, we are testing the create document, but it's not really in this file anymore. So what you need to do is we need to change this document service name. We can say create create document test, and we move it to the service. So now even inside here, I can do service with the repository, service.new, and everything should work okay now. Great, that works, but I just want to show you something. If also you refactor this, now you also don't have any cyclic dependency. But we're gonna use the external test because it kinda is better for us. Also the create document, we should refactor that, lowercase. Great. Okay, there's one more thing that I'd like to do. For the create service, I don't like the fact that we don't have any declared interface, meaning that you could be using multiple entry points and they kind of like have to look to see what functions are available. So that's not how I do things. So what we do is we're gonna say, hey, I have a type called document service, right? Or you can say iDocument service, whichever convention that suits you. In Go, we don't typically use the iDocument or like the I prefix kind of thing. I'm just gonna use it because I think sometimes it's a bit clearer and allows you to actually like reuse the actual concept that you want to do without an interface, without like shadowing the interface name. So the iDocument service, we said create document, which takes doc and returns an error, and all of a sudden our create document here implements that interface. Whoa, wonderful. And this is the beginning of ports and adapters, because now you can change how things are structured because you have an interface, so you can plug and play. Okay. We need to do some validations and some things on the document. All right, so let's go back to our conceptual thing. We kind of talked about a lot of stuff, so let's figure out where we stopped. We were writing down the rules, and we said, so a document must have an ID. Okay, well, we didn't really even like establish a way to create a document. Like even in our test, we just kind of like passed a document object, but we don't have like any method to create a document. So let's do that. So we need to be able to say create document or document dot new document, and here it should return you an ID. But let's look into our rules for a second. So a document must have an ID. Okay. That ID is generated when you create the document. So we'll generate an ID here. ID here. Document name is optional, so we could potentially have name. But if we do it like that, how would it be optional? Okay, we'll get back to that. Document must have a parent ID or root. Alright, so we've got a bunch of stuff. Let's start with the optional one because it's kind of similar to what we've done with the options configuration. So I'm gonna create again a type with sorry, this is a type option. That will be a function that takes a pointer to a document and returns an error. And here we'll say with name document name, and we'll say string, and that returns an option. And we can just say, implement method. Well, not implement method. I was trying to be lazy to return it, but screw it. It's easier to write it sometimes. So here we can say if name, well, if the name doesn't represent anything to us, then what kind of validation that we need to do on it, right? If it's an empty name, that's fine. If it's a space name, that's fine. Really, there is no name validations that we need to do, at least in this stage. Of course, from the API and sending the data, you will need to like make sure that it's there's like it's not possible to inject stuff into it. I'm trying to think of like, if you think about SQL injection, the way it works is like you would find the string, and that string is going to the database. They would inject SQL into it, and that will be evaluated. There was a term that I forgot that is used to actually like make sure that this is just a pure string that wouldn't take any effect into the database. Alright, so with document here, we're just gonna say document.name is equal to this name, and return. So this is with the document name. And now what else do we need? So we'll generate the UID. We handled the optional name. now with parent. So it will be similar concept. So func with parent ID. Well, now I realize that the with parent ID thing, it would actually happen from the service layer. It wouldn't happen to the document. So the document doesn't know that it has a parent ID or not. So that's an important distinction. So we don't have to worry about this here. I don't think it's needed, to be frank. And I can cast all of this to an ID. I just want to make sure that this returns a string and this returns, yeah. Okay, so the new document of course is containing because we have not returned document. Here you go. So we generated the UID, but we need to do this doc, return the doc, and we wanted to also return an error that's like we're passing things down the line for the error wise, and we say for each No, not for true. For each option. Again, range options. So here we need to take options. We gotta get a bit tired, guys, but we're almost there. For each option, here we're gonna say option. We're gonna pass the document with error, not nil. We return nil for the document, or into that, or again return an empty document to be error. So this way, it's kind of like you're always not returning nil for the document itself. Up to you how much savagery you want to be. So yeah, so if you want to be like, the reason why I'm saying savagery is because if you return nil, if you try to access it, then it will panic, which is not good, because you don't want them to like, you don't want to slap their hand to look into the errors, but they really should look into the errors, so it's up to you, it's your personal call. I think here, a new document, I will return it like that. And yeah, that's it. So we return the documents, we can check with names. Now if we go back to the create document service, so here we need to check for the parent ID, and we need to check for a few more things. And most likely what will end up happening is if it's only a couple of parameters, then you'll pass to the create document. If not, if there are like many, then you probably pass another data transfer object to Stripe. So next time we'll look into implementing the rules for this. So where we stopped, actually I can just put a, you know what, no, I'll just put it as comment to do implement rules evaluation for create document. That's number 1. And 2, we need to implement VTO if needed. And implement DB for create documents. So that's kind of what we have for the agenda for next time. What's wrong with this thing? Did I do that? You know what? Ah! Alright, this is what we have for the agenda for the next time. Great. So let's make sure one last thing. If we run the go test, that we're at least in a good position. Not quite sure why it's taking a minute there. It's taking quite a long time, which is giving me a bit of a suspicious feeling that something is up. So let me see what's going on, but I gotta make sure something here. Okay, it passed. I think just my computer's like extremely overwhelmed right now. Right. It's not actually that it's slow or anything, I just think that the computer is like so many things open. Alright, so we have the agenda for next time. And yeah, so we have the agenda for next time. Today we looked into the data model for how we're gonna build the documents and the segments. we started implementing the create document service, and we actually started implementing the inode table. And next time we might look into finishing the create document use case and implement that rest of the vertical slice. And once we do that, we will move on to implementing the segments, which will be the tree that we also looked into the conceptual model. Last thing that I want to make sure, last time I want to check where we left off. So I make sure that we are covering things that we said we'll cover. So last time we said we will implement the linked list solution, but we moved away from that and we explore that today. We start modeling our domain. We kind of did into like the documents and the segments, but this is not like using event storming or anything like that. So I would give this like a half point.